My name is Walter Willinger, Chief Scientist at NIKSUN, and I will be the moderator of today's webinar. It is my great pleasure to introduce our two guests, Dr. Ed Amoroso, CEO and founder of TAG Cyber, and our own Dr. Parag Pruthi, CEO and founder of NIKSUN. We begin with you, Ed. I imagine it must be nice to be able to go to bed these days without having to worry about all the networks that you were responsible during your time at AT&T. And so can you tell us a little bit about what you have been doing, in particular about your plans with the new company that you started, TAG Cyber?
Well, thanks, Walter. And old habits die slowly. So I think I still worry about not only AT&T's network, but the whole critical infrastructure across the U.S. and the globe. I think it's pretty obvious that the offense is clearly ahead of the defense. And some things have to be done in the next couple of years, or we might see some tough scenarios. So I still have the sad habit of worrying about that so much. TAG Cyber was basically founded to realize this dream I've had of democratizing cybersecurity intelligence and analysis and information about the industry and about great companies like NIKSUN. Most of the time, CISOs and enterprise teams have to really work hard to get their hands on good analysis, sometimes paying quite a bit of money. So as I said, it's always been my dream to democratize that, make that available for free. And I spend most of my time with my team trying to make that material available. And through today's discussion, I'm so glad we're focusing on virtualization in the context of the kind of network security solutions that you and Parag and the team there at NIKSUN build. So I'm looking forward to a very fun and interesting discussion. Thanks for including me.
Going right into this topic that you mentioned, virtualization. So I imagine that in your last years at CSO at AT&T Services, you saw the first phase of virtualization, and now as sort of spokesman for TAG Cyber, I assume you have been talking and advising CISOs in different companies around the globe about virtualization in particular, because it's a hot topic. And so based on these discussions and your experience, what do you see is driving virtualization for these companies and for the public and private sector?
No, it's a unique situation because, and I know Parag has seen this as well, most of the time, CIOs and network managers drive initiatives and drive evolution. That isn't always a big favorite with the security teams. A lot of times technology moves in a direction that makes our jobs much more difficult. It just turns out that virtualization, which, let's face it, is driven primarily at the infrastructure level to reduce costs and at the user level to increase speed and flexibility, particularly in provisioning. But those initiatives are driven by non-security goals, frankly, which makes it one of the rare cases where we have a tailwind behind us in cybersecurity, where the initiatives that are being pushed are things that we would have pushed anyway. So I've been going around telling a lot of the folks that I'm sure you speak to as well, hey, let's hitch our wagon to this. The idea of virtualizing infrastructure in particular to speed up provisioning. You need more compute, you provision it. You don't go through a 6-month planning cycle and wait for the trucks to deliver hardware to your data center. You don't do that anymore. Now you can do it on demand, and it changes everything. Now, there's still a great need for analytics, and there's still big pipes, and there's still a lot of infrastructure where we need to do heavy lifting. But all around that, you've got companies that are much more nimble, that have the ability to do things quickly, to do prototypes quickly, or in the best case, let's say you're under attack and you need some additional protection. You can imagine scenarios where the CISO is like a battlefield commander provisioning some more protection, like maybe clicking on a NIKSUN icon on some profile, like a portal or something, an SDN portal, and additional protection analytics would be deployed on demand. That's quite a wonderful vision. Yeah, we're not exactly there yet, but I see everything headed in that direction, and it's very good news for the people who are listening to this webinar and to people who are concerned with broad infrastructure security. So I'm pretty bullish about it.
So in some sense, you seem to say that virtualization makes life for enterprises easier. Now, what is it with respect to network security? Does it make life for enterprises easier as well, or does it make it in some degree harder or different?
Yeah, I mean, there are pros and cons, right? Like the primary pro is just the ability to more dynamically and more flexibly set up security architectures. And you can do defense in depth. Like, for example, if there's somebody listening right now who maybe does some network monitoring on some portion of their network, maybe during the year they just do it for things that they would consider critical. But there may be a time during the calendar, maybe it's a retail company that gets very busy, say, during the holiday season. They might like to just push a button and provision additional security. And in SDN, what happens is a process known as service chaining, where you've got a compute chain that is, in some sense, you can think of it as like a gauntlet from a security perspective. Well, you push a button and that gauntlet can extend itself to additional monitoring or additional DLP or additional SIM or whatever it is you decide you want to do. And that's really nice. Now, on the other side of the coin, a lot of people argue, well, cloud and virtualization reduce in some sense the diversity. Like you end up with one hypervisor level. You end up with hardware that looks all the same. And you could make the case that you do have to attend to that more carefully. But I always like the idea of put all your eggs in a basket and watch the basket carefully. I don't think the idea that going more common at the hypervisor level really introduces a great deal of additional risk. In fact, I think that the simplification might actually make things more secure. So you're right to say that it's an important consideration to look at both sides of the coin, but I think it's overwhelmingly positive for security teams as we move to software-defined networks and software-defined infrastructure. I think it's very exciting.
Let me turn to Parag for a minute here. And so Parag, we all know that you have been in the thick of network security for a long time, way before virtualization came along. And securing your customer's network was a problem then. And from what we hear from Ed, problem just maybe a different problem in the advent of virtualization and the cloud. So can you share with us sort of your view of why is it that the private and public sectors that have invested so much money in cybersecurity in the past are still facing essentially the same challenges in the future?
Thank you, Walter. First of all, I want to thank you for having me here today and to Ed for making the time to be part of this discussion. It is good to be with two of the world's most recognized men of science. And science is very good because we can base all our designs on some principles. And that's what I really think is the right approach going forward. But to answer your question is not a simple one because it's a bit complex. There are many competing forces here. But let me try to summarize what causes issues by way of some very simple illustration. And I'll only focus on one aspect. And that aspect is the fundamental problem is in understanding the meaning of simple and common terms and grasping the entirety of what is being advocated. Okay? Stay with me for a second. Let's focus on just one word, data. Okay? Just for a moment. We all know that practitioners lack data, and the holy grail of the problem is rooted in the data. But what data? So when I talk to CXOs about data, they say, we have all the data. We have everything we need. So then I go talk to the cybersecurity analyst in the same firm and ask them, okay, why is it that you were not able to catch and mitigate this issue or that issue? Inevitably, the answer comes out that they didn't have the data they needed. Interesting. So you go back now to the CXO and say that the data needed for the issue was not available. And the response is, that's not correct. We have all the data. We log everything. We have a SIM. We gather it all. We have APT malware analytics. And so we have all the data. And we use advanced data mining techniques as well on the data. You see, then I'll explain this basic issue and then I'll answer your question on virtualization and why we still have the challenges despite all the advances. So your basic issue is that due to a shortage of skilled practitioners in this field, the scientific understanding of the appropriate data to solve a particular problem is not known by many. And therefore, people wrongly have concluded that the sort of movement of reports by consultants telling you, what everyone else is doing is safe because everyone is on the same boat. You see? So the challenge is that when you get to virtualization, it becomes more complex because what data do you need to solve the cybersecurity problem in the virtualization area is still not well understood by people. Okay? So somewhere people think, oh, because I have virtualized everything and I can now handle all kinds of loads and I have various logging, I have all the data. I think that's the challenge. So what you have is, in the current situation, that there's always some data they're missing and they never have the data they need because a clever hacker knows that the data they're relying upon to do their security, and they go around the data and circumvent detection. So as you begin to think about it, because fundamentally you will find this common issue in people. I didn't have the data, I couldn't get it in time, it was not available, I didn't know where to get it, whatever. It's a lack of data. Okay? And you'll begin to realize that in reality, you don't have data for many, many attack vectors. And that new threats will be discovered continuously after someone has already exploited them. So this is a given. We're human beings, we write the software, it's complex, it's big, even though you could make a small container, but what is small today was huge yesterday, and so it's still huge from a human consumption perspective. And so you always have some vulnerabilities, and somebody will compromise it. So with this simple reflection, if you can stop to think about it, then you'll begin to realize you do not have all the data. Now, this conclusion has led some to wrongly conclude that it's impossible to get all the data. So they may again default to creating yet another layer of security to address a specific issue. Now, the challenge with that is that after a while, these layers in different disparate systems become impossible to manage and costly to maintain. And then you suffer from a backlash, okay? That I spend all this money and I get nothing in return, and you just want to buy more stuff, okay? So in kind of Ed's example earlier, where he said you can spin up stuff, okay, well, that's a good thing of virtualization, but you spin up a lot of stuff, you get sort of overwhelmed with a lot of stuff, okay? Because things are not then correlated down to the fundamental and essentially available to you. It's the needle in the haystack problem. Now, there are two distinct types of data, essentially, in an enterprise. One is the data that resides on servers or hosts or devices. It just sits there. We call that data at rest. Where NIKSUN is concerned with is if that data moves somewhere. In particular, if it moves somewhere unauthorized, by somebody unauthorized, to a place unauthorized, and so on and so forth, it's a big concern. You have this Equifax breach, unauthorized access to the data happened, and so that would be called data in motion, and it's bad data in motion, bad motion of that data. So you could have all sorts of devices in your network to log things, to detect things, but this one essential thing of the blind spots, you have not realized that how to solve that problem. And I already explained earlier that will continue to remain to be a problem as long as we have, humans writing code. So at NIKSUN, we said, okay, this is a real problem. How do we come up with a method by which we can collect each and every transaction that happens through the network, that is for data in motion? We want to bring that data in motion to data at rest so we can analyze it. Of course, we had to put controls in place for such tools to adhere to internal and external regulations. But for the moment, let's just say that you are able to capture all the transactions, and now you have a copy of all the data in motion. Then the next challenge is, and as an example, a breach happens, or you are simply looking for some anomaly, and you want to now inspect the data, right? So you need to have some system by which it is indexed, and then you need to visualize it. And you need to be able to do this across multiple silos of this data. So this is the key approach of NIKSUN. One, recognizing that you will always have vulnerabilities. Recognizing that the cat is always going to be somewhat ahead of you depending on the money and resources available to that cat. And that you will never have 100% security. So with that recognition, the thing is, how can I deal with this challenge? And if you come to think about it, in the physical world, we have security cameras. We just don't have doors and locks on them and logs of those doors. We also have security cameras. So if you go with that approach, then you can get this holistic security. I'm not saying not to do other things. I'm saying this is the missing piece, and this is the challenge.
Talking about blind spots. So when you interact with people who are in charge of cyber defense in the private and public sectors, how do you see that? Are the people aware that solutions that do away with less, meaning let's say sample net flow data versus full packet capture, that such solutions necessarily have blind spots that attackers will and can find and exploit?
Well, I think your team, the NIKSUN team, understands this perhaps as well as anybody on the planet. Parag is correct to say that one of the great, he used the word principle, I think it is a principle, no matter what you're running, is that you better have access to the data you need, meaning live information about what's going on. Or it could be configuration type related, it could be attack related, it could be telemetry that you're processing. So that's sort of the backdrop. Now, this issue of blind spot, actually, when you were asking me earlier about virtualization, I probably should have said that the potential for blind spots does increase maybe somewhat with virtualization, and it requires a pretty good monitoring infrastructure. It's probably not going to be just one tool. You need a whole set of processes and other things around. I'll give you a couple of examples. There are time-based gaps that emerge. For example, you're running some sort of a sampling algorithm across your network, and maybe they're VMs or workloads or little pieces of compute that get created dynamically. And there's no reason to believe that they couldn't be created very quickly, service a task, and then go away. It's possible that something could be provisioned inside a window where you're not monitoring. You just weren't doing it, and it's been killed long before you get around to looking at it. That's one potential gap. Another would be that you just don't have the proper coverage. So to the degree that you really embrace virtualization, you might potentially, if you're not managing it properly, see some sort of sprawl where there's all kinds of new projects that pop up, teams that don't have a legacy or a tradition in the company is maybe doing infrastructure that suddenly have accounts on AWS and they're spinning up compute and they're doing things, and you don't have it monitored. So then a blind spot emerges with that sort of thing. So it might be coverage. A third is the one you just alluded to, like embedded in the packet, in the data flow. If you decide that potentially maybe infrastructure is just getting too big, again, a byproduct of virtualization is that you do more computing. I don't know that you're going to be doing better, but you're definitely going to be doing more because it's cheaper and more available. It's possible that you may decide that you're going to adjust your sampling algorithm or adjust the kinds of things that you're looking at because you're just pulling too much data and you don't know what to do with it. Then you might have a gap in the sampling. So there's a lot of different places where blind spots might occur. None of them are acceptable. And the good news is you don't have to have those blind spots. There really are tools. I know you and Parag would be more than happy to share some of the things you guys are doing. But I do think that a consequence of massive virtualization is more computing and more ubiquitous use of cloud computing. Nobody would dispute that. So there is an attendant responsibility that comes with that as a consequence. But security teams just have to keep track of more stuff. So it's not bad. It's just there's more. And that extends to monitoring and collecting data. And I know at some point in the conversation, we'll talk about after you've collected the data, what do you do? And, clearly we're all going to be more dependent on automation and some advanced techniques like learning and so on. Those will become more important simply because there's more data, it's happening more quickly. It's just a bigger problem that needs to be solved. But we can do it. It's not an intractable problem by any means. So Parag is correct to point to data. And I think you're also correct in saying one of the things we really do need to make sure is that we're not exacerbating the problem of having blind spots or gaps in the data collection. I hope that's clear.
Yeah. So let me maybe just try to crystallize the question, or your answer maybe a little more. So understanding the full extent of blind spots in a virtualized world is possible, but will require some effort.
Yeah, I think so. And you've been at this a long time, that every company, every team, every infrastructure will be different. Everyone will have a slightly different set of problems, but this broad category of gaps or blind spots has always been a nagging problem. And it comes from a lot of different things. Well, here's one good thing that I think will happen. For customers of yours or people that we've all been known or people we've worked with who in the past have said or made the following statement, I can't do a full network monitoring solution because I don't have enough budget. I'm sure you've heard that before. Because the hardware deployments traditionally have been very, very difficult. I think as all tools, including yours, as they become lighter and more virtual, I suspect it's going to be easier for people to buy them. They become more embedded. I just have a feeling that with the growth of the industry that you guys are part of, it's going to become easier for people to actually extend their monitoring solution. But I'm interested to hear what Parag thinks, but I think it's hard to generalize what everyone's gap will be. There will be gaps. It's just, a bank versus a telecom versus government versus retail. I suspect they're going to all have different types of gap. Like I said, it could be time-based, it could be protocol-based, it could be coverage-based, it could be budget, it could be all sorts of reasons why it exists, but it does have to be solved.
Yeah, so I was just going to check with Parag in terms of, given that traditional approaches are lacking when it comes to protection of virtualized networks, cloud environments. So how is NIKSUN approaching this growing need of enterprises to provide full visibility into their hybrid public-private cloud-based infrastructures?
Okay. You have to have a sort of foresight, a vision of what you want to do, because what I find is a lot of approaches to any kind of an engineering problem or a security problem in particular, people will build solutions just to address that. and not think of the long-term future because there is short-term gain to be had. But at Nixon, I decided long time ago to ensure that we build a platform, an engineering-focused company. Why? Because obviously I cannot predict what the problem is tomorrow. But whatever intellectual property we create today over here can be applicable over there tomorrow. How do you kind of address that without having to re-engineer everything? So, as a fundamental principle, everything we do must be reusable software, that is. Okay. So that's my first challenge to my engineering team. That I don't want a one-off. I want everything to be reusable. And so we kind of take this library approach. Okay, you build it once and you reuse it many times, and then you can piece it together in a pluggable manner for adapting to certain environment. So let's take what Ed said. So you have an enterprise customer that could be in retail, and then you have a financial customer that is dealing with market data feed, for example. Now, how do you take this core engineering that you've done and apply it to both these environments, for example? Well, people build companies just to cater to the financial markets. People build companies just to cater to the retail industry for what they may need in terms of monitoring and cybersecurity. But with the Nixon platform approach, with this pluggable architecture of the software, it is very easy for us to reuse what works best for a particular common problem set, whether the issue be in a fraud in market data or it be in a transaction on a retail side. Do you see? So having this kind of design up front and trying to build that is obviously very costly because you have to build the whole platform. You build a car, the big cost goes into this chassis, right? It's $1 billion or so of engineering design to build a chassis around which the car will be designed. That's where all the investment goes in. But once you have that, you can crank up models like anything. So think of Nixon as this kind of a dynamic now engineering company that has a very strong foundation underneath. And so we can adapt our solutions, and we have, from physical infrastructures to the virtual, because think of it, our solutions already had to be virtual in the beginning to work in the diversity of hardware and distributed hardware that we had. And so from virtual to the cloud is a simple leap, because the challenge was how to scale this to correlate and aggregate all this data at high rates in the physical environment. Now you add cloud to it and the data is sitting over there. And we have all the security mechanisms by which to securely get this data, so that data itself is very important. We also protect that. I just want to mention that. All of this is combined to give, I think, a very viable solution across the enterprise to our clients.
So is it, just to follow up, is it then fair to say that Nixon's customer can be assured that even with virtualization in the cloud, they continue to successfully defy this Murphy's Law and will always have the right data at their fingertips?
Well, the restriction is only in that issue that Ed sort of brought up, which is what's the budget and what can I accomplish? Now, most people, if they say, okay, I'm going to need so much money to do all of this stuff, which is, as Ed said earlier, can turn them off, let's say. The problem is you can't escape that. So we already know you cannot escape not going in this direction. Eventually, you're going to have to go in this direction. Why not start out with a good architecture and grow it over time? And having this distributed solution from Nixon allows you to do that. So, for example, somebody may say, well, I want coverage everywhere, but you can't afford to cover everywhere. Well, where is the most important data? Okay, it's on these servers here. Let's start there. But now we have an architecture where you can easily plug things into that architecture as you grow your business, as you expand your business, and you're not doing ad hoc design principles, reacting to one problem or the other in the future, do you see? So this is the benefit.
Let me change topic slightly, Ed, and go back to you in terms of, so as you already alluded to, once you have the data, you better show that you are able to do something with the data. So now whether we talk about enterprise networks or data center networks, even today's data rates and the extent of these networks, collecting big data is in general very easy and is routinely done in one form or the other. Whether the right data is collected is a different problem, and yet a different problem is then analyzing this data and doing it in almost real time. So now there is currently lots of excitement and also some hype about machine learning powered AI, meaning artificial intelligence systems for cybersecurity. So Ed, how do you see these developments?
Well, I think they're good developments. Like you go back to the original Donald Knuth algorithms in the volumes he wrote back 30 years ago. And everybody noticed that an important primitive was sorting, right? So you needed to learn to sort data. So most of the early research in algorithms was about how to make some sense out of data. And then second primitive was searching. Like how do you find things in big, lists of data or sequences of data, or neither list nor sequence, jumbled sets of information? How do I find things? How do I search? And we've all seen how search has changed our lives in the way Google and others have transformed that. Well, a primitive that emerged maybe 10, 15 years ago in security is a primitive known as correlation, where we look at something and I say, wow, this is related to that somehow. I see this thing over here and I see this thing over there, and they're kind of similar. They both share a time, or they share a source, or they share something. And most of the early intrusion detection tools were built off of that primitive. And it's still valid, just as sorting and searching are valid. Correlation is still valid. These things don't go away. But what a primitive that sort of is driving this concept of learning is something called matching, and some people use the term labeling, where I give you a set of information, data, and I assign labels to it. And I say, look, all of these things have this characteristic, and I'd like you to look at this and see if you can't take that labeling pattern that I've shown you and now go off on your own and find other things that share the same label. And if I can do that, the word learning comes to mind, even though I'm not a big fan of these anthropomorphic interpretations of computing. I think artificial intelligence, unfortunately, is a bad term, but it's good computer science. This idea of labeling data, and whether you train deliberately, like in machine learning, or if you train on live raw data using massive parallelism, as you see in deep learning, these are excellent computing techniques. And then once you do that, once you assign labels dynamically based on these quote unquote learning methods, then the next primitive is the old sorting, right? Like you see a lot of young kids learning machine learning now. They're learning the tools, and they're drawing these algorithms out where you take a bunch of data, and I'm sure Parag laughs at this because these are things we were doing years ago, and they cut lines through them and sort them into different groups, and use these distance algorithms for kind of optimizing the way you sort things into subgroups. Those are not necessarily new algorithms, but once you do it, you've done a nice job of learning to assign labels to things you found, sorting them into groups, and then with each of those little groups, you can then feed little decision algorithms. You can call them, some people equate this to the neural networks, where you've got a bunch of neurons that each have a small subtask that they do, and you feed the little grouped category of stuff that you labeled into one of those nodes. You build a massive parallel tree of these things into a big decision structure, and that's AI. I mean, in a nutshell, it's really, it's not mystical, it's not machine thinking. It's just we've introduced a new primitive, this idea of label matching, that I think is wonderful. And it's cool that we can write programs that can kind of say, here's what a cat looks like. Here's another cat. Here's another cat. Here's another cat. Here's another cat. Now, Can you write a program to kind of see what you see there in many dimensions, machine vision, again, using lots and lots and lots of different characteristics that label pieces of the cat picture, and then feed that off into some new data and see if you can recognize the cat. And as you know, Walter and Parag, the techniques have gotten pretty good. You mentioned the word hype earlier. I think the hype part is the part that's unlikely to continue. I think the hype around thinking and using intelligence, and I don't buy that. I think that's the alchemy of computing, just as numerology spins off from math and as astrology spins off from astronomy. I think a lot of that silliness spins off from computing, and what we end up with are very solid algorithms, whether you want to call them learning or AI or whatever. I think they're solid, and I think they help us with all that data that the NIKSUN tool collects. You guys collect a lot of data, and we need to get better at doing something with it. So those are my thoughts.
I think very much agree with your sort of perspective on the unfortunate aspect of AI, but maybe probing one step deeper. So, lots of people look at AI in terms of, okay, would like to do unsupervised learning, so we don't have the human in the loop anymore, on weak signals in almost real time with essentially no false alerts. And I think while AI has been awesome in some contexts, which you already sort of mentioned, so, tagging pictures, recommending movies and things, do you see those types of techniques for cybersecurity? Is that a good match?
Well, it's a good match for a subgroup of the kinds of things we think about. Like, is it a good match for being predictive around the advanced persistent threat actor? Probably not. Is it a good match for looking at many, 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 many different files and kind of learning what a piece of malware or a variant might look like? Yeah, I mean, it's a really good application. That's exactly the kind of thing that you want. So, for example, if I've got my NIKSUN running and collecting tons of data, there are going to be patterns in there that I think we can train. And it's not going to be everything. You're not going to be able to use AI to make some magical prediction about something. But I think you will be able to use AI if you decide, I'm collecting all this data. I'm able to, in some sense, guide, whether it be supervised or unsupervised. And I never quite understood, why everybody writes off supervised totally, because there's certainly applications where you don't care about the supervision. So what? I mean, I know vendors tend to fight on whether it's supervised or unsupervised. There are cases where it could be perfectly fine. But nevertheless, I do think there will be usefulness in taking all of that data and answering specific problems that we have trouble with now. And you both know that if you had to pick one thing that has been the Achilles heel of computing, it's variance.
I go back to Parag and sort of ask him basically the same question. So how do you see AI as a match for cybersecurity?
Okay, so I think, Ed told us that there are certain areas that are good match and certain that are not. So I definitely agree with that. Those problems that require a lot of training data and are amenable to machine learning techniques are good. However, the fundamental thing that one should take away from Ed's comments are the data. So where do you get the data and what is that data? So you have lots of sources of data. Now, when we talk about lots of sources of data in the enterprise, our challenge becomes it's actually not data from a single source. So there are multiple devices with multiple clocks sampling and aggregating data. And so it's very hard with the volley of information coming at you to try to take that and have a machine sort of normalize it without a single source, okay, on which all the data or the foundation of the data resides. So this is where the NIKSUN approach is. It says, okay, every flow that I'm going to see in and out of your data center, every flow in and out of your web server, mail server, whatever are your vulnerable points, we will have a single source of truth. We will create a time-synchronized aggregate information of data from multiple different nodes in our network, and that will be done by a NIKSUN-like device. So what you have is then making conclusions from that, whether you do it by just algorithms or you do it by some sort of pattern recognition system, becomes founded on something real. Because what we found is if you don't do that and you want to take some automation step to do something with a conclusion that you've drawn, you actually can end up DDoSing yourself. Because machine learning is very sensitive to drifts in data, okay? And it's very hard to synchronize it. If you actually work on this problem, you'll find that aggregate data is very hard to go back to the course data. Once you sampled it, it's very difficult to find what was in a thousandth of a scale of time underneath. And if you spread it in a certain way, you can get very different conclusions. So just from that, the approach we have taken is that even AI is pinned on accuracy of the data in the first place, and then where do you get the data? And so the algorithms that we write and that our expert systems do try best to use the richest and finest data first before relying on some other data. And that just happens to be residing on a NIKSUN.
So, I mean, it sounds like taking your perspective and Ed's perspective together, there's a common denominator, and that is you both think really one of the key issues is underlying good data to do any sort of analytics.
Yes, I think actually it's this old principle of garbage in, garbage out, right? So you can have a great algorithm, whether it be machine learning or AI technique or whatever, but you feed it garbage in, you will get garbage out. It's very hard for a machine to make something good out of garbage.
And so at NIKSUN, Parag, you basically sort of approached and solved this problem by ensuring that the analysts have all the data that they possibly need at their fingertips at all time. Is that correct?
That's like the ideal, correct? And so we want to reach that ideal. So what NIKSUN provides you is the foundation to begin building towards that ideal. Because from a scientific perspective, this is what you need to do in addition to all the things that, are needed. I'm not saying other things are not needed, but this blind spot thing is never going away, and you have to address it. If you have to address it, you need a good scalable architecture and a system to do so. And NIKSUN has been doing that for the last 20 years and perfecting this.
And turning back to add on this stuff, so you already alluded to it in terms of, you certainly are appreciating the need for very good data. And so you seem to be convinced of the essential role that data will play in advancing cybersecurity as well. You agree with that sort of emphasis on good data as a basis and then analytics on top of it?
There's no question about it. I mean, that's probably, if there's an axiom around network security, it would be that you need to collect. And a lot of times people would use the term telemetry. And I know you guys use it more broad, but maybe a lot of the people listening on the call would be thinking in the context of as network activity, proceeds across infrastructure, you need to pull telemetry on what's going on. That will never change. I don't think I can't think of anything, at least architecturally or evolution-wise, that will change that basic fact. Now, the good news is you can automate a lot more of it. You're not going to be able to sit there in human time and riff through data, make human time decisions around what you're collecting. It's not going to happen. But what can happen is the telemetry can feed advanced algorithms, and then it can key off alerts of directives, actionable suggestions, and that's where the human beings can sit at in a SOC or at a monitor or at a workstation where you're in front of a pane of glass and make human time decisions. So I think it's one of the brighter spots. I know, Walter and Parag, you guys both know I kind of cover the whole industry, and there are places where I do see big problems ahead. But I think the concept of pulling telemetry, pulling data, and processing it is one of the bright spots in computing security. That a lot of people know that I tend to be a little bit of a curmudgeon at times. This is one of the areas where I'm pretty bullish. I think the work that you guys do is important. I hope you keep doing it for a long time, and I hope that people listening take this concept of monitoring and pulling data and making sense of it very seriously, because you have problems if you don't do it.
And so again, I mean, it looks like there is a sort of a very nice common denominator between what you are sort of telling us and what Parag says in terms of automate what can be automated with whatever techniques you have, and then bring in the domain expert for those few things that remain, and make best use of that sort of combination of options.
That's right. That's right.
Okay.
Totally agree. No, that's the right algorithm. I think Parag would agree that as you go through that, there's probably an iterative cycle where those domain experts can find opportunities to continue to automate it. We should always be in a process of learning and continuing to improve the automation, because the problem just continues to change. Cybersecurity is one of those weird things where you figure out an attack or a threat, you get very good at dealing with it, and guess what? Congratulations, bad guy's going to do something different. So you can't ever get too complacent. It's probably it's a cycle that goes on forever, and that's why I think having an objective amongst any SOC team of trying to automate anything you're doing, with full recognition that you're going to have to do a lot of manual stuff. Anybody who's ever worked in an operations center doing analytics knows full well that it would be silly to even imagine that you automate everything. But that should sort of be the goal. That should be, even if it's unattainable, it should be always the question: can we find a way to write a tool to do this? And if you can, then do it. Or speak with your vendor. And I know you guys listen to your customers all the time. If something can be automated, automate it by all means. We've got a hard job that we do here.
Well, thanks, Ed. And I think we could go on for another hour discussing this topic alone. But we are getting close to the end of the webinar, and I just would like to get back to some of the questions that have been asked during the webinar by attendees. And so let me just go and read the first question. So, do you see the industry leaning towards AI interfaces or machine learning? Parag, would you?
I think the problem is inverted, actually, which is you don't want something to come in and sort of say, this is what you should be capturing, because in limited scope, yes, you can do that. Ideally, what you want to do is, you don't know what attack is going to happen. So if you are later saying, organize the data this way, it's a little bit too late. Okay. So you want a streaming database that is continuously organizing itself based on certain rules that allow for queries to be achieved in fast time. And that's what NIKSUN does. NIKSUN has a streaming distributed data warehouse, and the NetOmni that NIKSUN has allows one central way to query, petabytes and petabytes of this information and get the results back quickly. So AI would be a feed from our database. It would be getting the data each one of those algorithms needs for specific conclusion through a NIKSUN API. So that's the way this integration is going.
And then just a follow-up question on this. So the question is basically, is the data scored to rank and based on its ability to provide cyber forensic value, or is all data created and ingested equally?
Well, all data is created and ingested equally, but it is categorized differently. So in other words, yes, it is created equally, but then there are running algorithms in the NIKSUN system that are also analyzing the data. It's not just capture and keep. They're actually mining the data continuously, and they ensure that the data, once it is identified with particular vulnerabilities or challenges in that the customer is trying, or people are trying to look for, then it is reclassified as being critical for certain functions, or maybe just informational, as an example, right? So that's the approach. So the data is all treated equally until something is detected within it, and the detection within it is not necessarily based on content, but could be based on volume or other sorts of metrics.
Ed, I think I have a question here for you. So the question is, do you think that the distributed database over a wide area network could avoid a breach like Equifax?
And probably not. I think that the issue in with Equifax was a reasonably well-known vulnerability that hadn't been dealt with, superimposed onto a perimeter architecture. So as long as people are still trying to protect data behind a perimeter firewall, we're going to continue to see the kinds of breaches that you see with Equifax. Look, would it make sense to be collecting distributed data and have better visibility into what's going on? Of course. Is it possible that you might have picked something up? Yeah, I mean, maybe it's a stretch. It's certainly possible. I think all of these are things that you need to do. But the one area I mentioned earlier, I'm not. I can be somewhat of a curmudgeon. If there's one place where I am a curmudgeon, it's in this area of preventive data security. Keeping customer records and other types of databases away from prying eyes using a firewall perimeter. I don't think that works, and I think far too many companies continue to rely on it. So that's my answer.
Okay, so I think we have to deal with the practical world today. There are vulnerabilities that have been discovered and not patched. There will be new vulnerabilities undiscovered and utilized. And the only way to deal with them is to get some sort of a sensor on them. Okay? Because otherwise, your months go by before you find anything, and you typically find something. How? I think this is not a secret. Someone else tells you, hey, this is going on with your network, or you're being hacked. Well, how can you, the enterprise, protect yourself without visibility? So in that, I slightly differ from Ed's view, although he's talking about an ideal at the end where we should be targeting, which is correct. But you have to get there. So what do? You can't rip and replace everything today. It exists. You have to deal with it. And as you move forward, then you put in all of the appropriate controls. But there's nothing to say that the administrator didn't get hacked and his computer wasn't used to access the data who had access, for example. So there are these challenges, and they'll always be there. So I think, you have to be pragmatic, and you have to say, yes, it's not a silver bullet. There is no silver bullet, but it raises your ability to not only find things that you may not be able to find otherwise, and hopefully curtail them before they become a huge nuisance or a problem.
So before we finish up, here is one other question for Ed, somebody who read your recent Tech Cybers, where you argue strongly for the three-word mantra: explode, offload, and reload. Can you briefly explain this and discuss it in the context of what we just sort of discussed?
Oh, sure. Well, I think that, as I said earlier, if you have an infrastructure that's a big perimeter bubble, then the best thing you can do is put a bullet through it and explode it into little pieces, break up your workloads, and distribute your system. And any computer scientist will tell you that a distributed system is going to be more robust and resilient than a centralized one. So that's the first thing, break up your infrastructure. The second, the offload means that virtualization in the context of cloud and service providers is a powerful concept. There are going to be people around who probably can host and manage your infrastructure as well or better than you can. So you need to partner with them. That doesn't mean you're not running an enterprise. It doesn't mean you're not building networks. It's just you've got a partner. And then the third piece is kind of where the NIKSUN part comes in. That means reload with all the great stuff that's coming out now. If you've got old tools that you put in place 10 years ago, take advantage of the new architecture you're putting in place to revamp and rethink who your partners are. And you can buy the best of everything now because if you're redoing, and it's sort of like, when you clean out the garage and then you take a look and say, wow, I could actually, put some new shelves in here and clean up, a little new paint. It's that kind of thing. As you're redoing your architecture, reload with the best available security technology. So that's why I say explode the infrastructure, offload onto virtual, and then reload with all the best security capabilities that are there. That's what I'm advising every CISO on the planet to do in 2018 and into the next couple of years.
So Parag, is that also the same on your mind?
I think so. This is, I think, what we're saying. The challenge, as I said, is that people may misinterpret a particular statement to mean something different. But I think both Ed and I think every other cybersecurity expert will tell you that as you are moving forward, you need to be rethinking the problem and putting in the base today of a solution that is scalable and can work for you down the road. Don't take a reactive approach and try to do something without thinking about it. And if you ground your decision making on science and data, you're on the right path.
So with that, I would like to extend special thanks to Ed and Parag. Ed, many thanks for participating in this very informative webinar and for sharing your expertise and insights with us, and also for sharing your optimism, I guess, about the future with us. Maybe some final comments from you?
No, my pleasure being part of the discussion, and I really enjoyed it. Thank you.
Similar, many thanks to you for your participation and for describing the amazing technologies that you are making their way into our solutions, and promise to keep NIKSUN at the forefront of modern cybersecurity. Any final comments by you?
I think this has been great. Every time I meet Ed, I learn something. And I learned a great deal today. And Walter, you are a harbinger of knowledge. So the way you have sort of conducted this and got stuff to kind of come together, I think this is just wonderful. For me as a participant, also as somebody that's hearing what you and Ed are talking about, it was a great experience. So I think I really, really thank you both for sharing your time with us and for educating us.
Thank you all again for joining us today. This concludes webinar.